first nuclear power hall, just to make people aware that things are not the way only they are being presented by some people, but they can have all sort of information about that, how safe they are. Unfortunately, people have the first encounter maybe with nuclear, so they have some fear in that. So that's why this hall came. Then later on in Delhi also, it came up. And now we'll be renovating this with the help of, again, Nuclear Power Corporation of India Limited. Uh, I have got an opportunity to visit one of the site, and it's really, many people have apprehension that it creates some problem with the environment also, and maybe radiations and all that. But until unless, as we do, we should not believe blindfold. We should go to the depth of that. We should try to collect data. We should try to understand whether things are being presented, they are correct or not. Because nowadays it is, during Corona, we have come across infodemic. There's a lot of information there, like pandemic. So sometimes it is being created that way, and only those things are presented. But if you go to the gallery and find out all information, you will find there are not many things which are very positive. And environment is one concern, because thermal power or many other means, we always we are using the largest amount of electricity is coming from thermal power stations, which has a lot of carbon footprint and a lot of pollution also. So we are, Agenda 2030, we have already signed, Government of India, that we will reduce these emissions or carbon footprint. So we need to go for some other source of energy, which is free, good for environment. So we are today we will be discussing about nuclear power and environment. What normally is being presented, whether it is true or not, how true, how if it is true, how much, if it is not, then what, where we are wrong. And to tell this, we have with us Dr. M Nautiyal, Chandramohan Nautiyal. That is his full name. I had an opportunity when I was in Lucknow to work under his guidance, because he was our local advisory committee members. But apart from that, when you say Dr. CM Nautiyal, if you are in Lucknow, then I think, and you are related with science, then everybody will know about him. He is not only a scientist, he set up his own lab in BSIP, Birbal Sahni Institute of, now it is called Paleo Sciences. At that time, it was Paleo, I think, botany, something like that. So he set up his own radioisotope lab, and we have also got opportunity to visit that. Apart from that, he is a good science communicator also. There are thousands of article, book, radio programs, lectures. What to say? Means there are more than 1,000 of them. And he's well associated with science popularization network like Vigyan Prasar, NCSC, Inspire program, and throughout India he has given lectures and guided. He trains also. In fact, he guides his students also how to communicate science through written media, through print media, through television, through radio programs, how to speak, even the script writing also. I have got this all means guidance also, and attended some of the program conducted by him. And he's very known and very good friend of science centers. I will say now NCSM, because he's connected with us also in Mumbai. He's connected with Lucknow also, and NCSM as a whole. Dr. Nautiyal has many honors under his belt, I should say. Meteorological travel grant award, INSA medal, Young Scientist Award in 1988. And ISMAS prize in 1988, BSIP consultancy medal in 2008, Vigyan Vachaspati in 1997, Vigyan Ratna, Vigyan Jyoti, and UP Vigyan Sancharak Vigyan Parishad centenary honor in 2012, Bharatiya Bhasha Pratisthapan Samman in 2013, best poster by him in 2013. Paper of the Month by BSIP in 2014. Now he is retired and is connected with INSA, Indian National Science Academy. He is program coordinator and consultant, more of that, and organizing regularly And now I should say, he's admin also of one of the group where I'm also a member, which is Science Matters, which is purely a platform where science communicators, scientists, they are there and they are discussing a lot of scientific matter and current issues. So I think with this, I'll request Dr. Nautiyal to take over and start his deliberation on nuclear power and our environment. Over to you, sir.
Thank you so much, Umeshi. And the way he is appreciated, he's a very good friend of mine, you can judge. We have known each other for a long time, and he's a fantastic communicator. And now he's at Mumbai, but we keep meeting on different platforms. So this happens to be just yet another. I'm very happy that there are quite a few people to listen to this program. I have been associated with a program earlier where we wanted to tell people why nuclear energy is good. And in the course of that, I realized that we are on one hand talking about improving this environment, making this earth a better place to live on, but at the same time, we are spoiling the atmosphere. The climate, as we know, is changing. We see that there is a lot of pollution. Now, all these problems have to be tackled, but there are some efforts which we do at our individual level. There are some efforts which we will have to do at institutional levels. And one of the very big efforts which has to be pursued at national level is choosing the right kind of energy. Just because I am talking about nuclear energy, I don't want to convey that nuclear energy is the only way we should go about for using energy or generating energy. But this is definitely one of the most friendly energy as far as our climate is concerned. And in the course of this lecture, I'll be discussing with you why nuclear energy is good, why nuclear energy generation takes us into several other domains which are very good for the society. We have been able to use nuclear devices, isotopes, radioactive material for many things, not only in the pure research, but also in our daily life, and about them we don't even know. So I would like to tell you why nuclear science is important and how it can play a very important role in making this earth a better place to be. In many of the cultures, including our own Indian culture, we call it Mother Earth. In some of the societies, they call her Gaia, that again means Mother Earth. And actually, Earth could be treated as a living being because whatever we do that affects this Earth. As a tribal leader from the South America had once said that whatever you do to Earth, you get it back. If you spit on it, you get a spitting back. So I will be telling you about nuclear energy. Before that, I will like to explain to you in detail the condition of our environment today. And then you will realize why we have to seriously think about the new approaches to energy consumption. I'll start with this PPT. Are you able to see that?
Sir, we can see. You can make it full screen. Okay.
Oh, yeah, now.
Yeah, now it is full screen.
The scope of this lecture is that we'll talk about the pollution that has been increasing. It has been spoiling air, water, soil, oceans, river, everything on which we depend to live a decent life. It affects the health and quality of life. And most importantly, it affects the weakest, that is the children. Therefore, we need a development which does not damage the environment. But what do we do about that? We will, by the end of the lecture, I'm sure that each one of us would have realized that nuclear energy is one of the best options as energy in this world. Now, why? I will tell you. Let us look at the environment today. We watch that there is an increase in temperature. Another important thing I must tell you is when we say climate change, we don't mean just an increase in temperature. By climate change, we mean increase in the frequency of extreme events, which means floods will also increase, famine will also increase. As you have seen that in the southern India this year, there have been flooding. In the northeast, there has been flooding. But in the state of UP, for example, it has hardly rained this year so far. This inequality in the distribution of rain, this inequality in the distribution of rain over time is what characteristically defines climate change. We are having more and more cyclones, we are having more and more floods, we are having more and more droughts, and all these things make our lives very difficult this earth. Actually, the climate change, as W.S. Broker, a professor at Columbia University some time back, he said, climate is a beast and we are poking it with a stick. It's just like when you want to excite an animal, it will attack. You are poking it with sticks, so ultimately it's you who have to worry what the consequences will be. The issue of climate is serious, but many of you don't realize that the issue of climate is very closely linked to the issue of energy. At one time, maybe 2 decades ago, everybody thought a society which uses maximum amount of energy is the most developed society. Because people were always finding ways how to generate energy. But now the situation has come that perhaps we will have to define that society as the most advanced, which uses energy to the minimum, because in today's scenario, generation of energy requires, generation of energy means we can consume it, and if we generate more energy, we are polluting the environment. As Umeshji had just said, most of the energy in this world is being generated by thermal power stations, thermal power reactors, where coal is burned. And it's very obvious that coal is made dominatingly of carbon. If you burn coal, you will be generating carbon dioxide, carbon monoxide, and even some sulfur dioxide and some other toxic gases, which all go into the atmosphere, make it more and more toxic. And today we see that the carbon dioxide level in the atmosphere is reached more than 400 parts per million. You may perhaps be knowing, before this civilization, this culture of industrialization started, it was barely 260 parts per million. That means the increase has been more than 50%. And if we don't stop pumping more and more carbon dioxide in the atmosphere, things are going to be very bad. Perhaps one day, even the ice or the snow and the glaciers in polar areas will start melting. And a day will come when ocean, which absorbs a huge amount of carbon dioxide today, will stop absorbing this carbon dioxide. And the result will be that this carbon dioxide will remain in the atmosphere, making it very difficult for any living being to survive. We have to find ways how to mitigate the climate change. And the essential step is looking at our sources of energy and picking up those energy sources which are friendly to our environment. We will realize during the course of the lecture that nuclear energy and the nuclear science can help a lot in this respect. Why does the climate change? The climate changes not only because of our activity, but it also changes because of some natural changes. For example, if the radiation coming from the sun increases or decreases, the temperature will change. So there are astronomical factors. If the angle of Earth with respect to the sun or our orbit changes, we will be receiving more or less heat. Similarly, volcanic eruption can bring about a change because there is emanation of lot of dust and particle and gases into the atmosphere. Tsunamis can do it. Earthquakes can sometimes release gases. Similarly, there is a lot of flooding and other things happening on Earth today, which are changing our environment and ultimately changing the climate. But the question is, if I tell you that last few hundred years have been the most stable time, most stable years in the history of mankind, you would be surprised. And the reason is, earlier there have been more higher temperature, there have been higher sea level. Today the things are actually better. But earlier the man did not exist. The human beings were not there on this earth. So even though the sea level was higher, it did not affect any human being. Even though the temperature was higher, carbon dioxide was more during certain stages, it did not affect human beings. But today we are here. temperature goes up by 1 degree Celsius, people switch on their air conditioners, people switch on their coolers, people switch on their fans, and the result is lot of extra energy is consumed. And any consumption of energy means higher generation of energy. And in today's scenario, higher generation of energy means higher burning of coal, which means more carbon dioxide, sulfur dioxide, and carbon monoxide in the atmosphere. Therefore, we have to take care that we don't change the atmosphere so much. We all have been talking about the greenhouse effect. I don't think many of us exactly know what greenhouse effect is. What happens is during the daytime, sun emits a lot of radiation, and we know that the surface of the sun is at about 6,000 degree temperature. Now, the radiation which comes at this temperature is rich in higher frequencies, but at the night, when Earth is radiating back the heat absorbed during the daytime, this is dominated at 20 degrees Celsius, 30 degrees Celsius, or 40 degrees Celsius. And therefore, this is dominated by the longer wavelength, which includes infrared radiation or the heat. Now, this radiation can be absorbed by the clouds, by the air, by the carbon dioxide in the atmosphere, by the ozone in the stratosphere. The net result is during daytime, radiation comes at a higher frequency. During nighttime, it goes back at a smaller frequency or at higher wavelength, and therefore this is absorbed in the atmosphere. This is not very bad, because if it were not there, the temperature on Earth during night would have been below 0 degrees Celsius. But now, what is happening is gradually this accumulation of heat is going up and up. The concentration of carbon dioxide is increasing day by day, and the result is the temperature on Earth is going up. Not only that, more importantly, because of our industrial activities, because of agriculture, because of change in the land use, all these factors contribute to the change in carbon dioxide in the atmosphere, and therefore the frequency of extreme events has been increasing, which is bad for our Earth, for our lives. I understand that many of the people who are listening to the lectures are very young. I will just tell them on the x-axis, we show the time before today, how many thousand years before. And on y-axis, you see the level of dust and also of temperature. The upper graph in blue color shows you the variation in temperature. It has been changing. And this has been correlated with the increase in the carbon dioxide and methane in the atmosphere. So energy, environment, and climate are all linked, and we have been observing the changes that are taking place. What can we do? This is one response. You say that, okay, what can we do? हम क्या कर सकते हैं? कुछ नहीं कर सकते. And the second possible reaction is, what can we do? We think about what we can do to improve the situation and save ourselves. Another misunderstanding I must clarify. We are not saving the Earth. We are not talking about saving the Earth. Earth has been there for 4.5 billion years. We have to save ourselves. Earth will continue to be there for billions of years. It's only we who will be worried. And if we don't stop or mitigate the climate change, we will have very bad consequences. We have known about the extreme summers that Europe has been witnessing. We have seen the condition in our own country. We have seen how species have been vanishing. We have seen how people migrate from one place to the other, disturbing the demographic distribution or the constitution of the society on this earth, and therefore a lot of problems come up. Agriculture gets affected. Rice yield can go down by 0.7 ton per hectare if temperature increases just from 22 degrees to 23 or 24 degrees. Similarly, rice yield can go down if the temperature goes lower. So whether the temperature goes high or whether temperature goes up, our problem will be we will not know when to sow our seed. And if that happens, agriculture will be affected. But nuclear technique, even here, can help us in improving the varieties of seeds. And I will talk about it at the end of the lecture. Tomatoes and chilies are very vulnerable to extreme temperatures. Rice has different varieties, maybe early maturing and late maturing, but we should know the conditions or the weather or the season pattern in advance so that we sow them at the right time. But if they are disturbed because of the change in climate, we'll be losing our crops and there may be famine on Earth. But even here, nuclear technology can help us because nuclear techniques can help us in enhancing the shelf life of these fruit, these vegetables, these food grains, which otherwise can get exhausted. They get waste. They are spoiled if they are kept for a long time. But even here, nuclear technology can help. Per capita availability of milk in our country has improved in the last few decades. In UP is slightly better than the national average. But you know very well that we will get more milk if the cattle, that is the cow and the buffaloes, are feeling comfortable. If they're not feeling comfortable, they will give less milk. And this has been experimentally demonstrated. This is particularly true of the buffaloes and cows, which are imported from Europe or other countries. Which means if there is a change in climate, our milk supply will also get affected. If there is an increase in temperature on Earth, the carbon dioxide, which was naturally getting dissolved in oceans, will stop doing so. It's just like if there is a soda water bottle and the cold drink bottle. If this is at a high temperature, when you open it, the gas immediately escapes. But if the soda water bottle or the cold drink bottle is in a fridge, then you will see when you open it, the gas doesn't escape. It remains there. Similarly, the oceans, because their temperature is increasing, will absorb less and less carbon dioxide, and therefore carbon dioxide in the atmosphere will increase. This means the animals living in the ocean will also be affected. A lot of carbon dioxide gets converted into skeletons of the animals. It gets converted into some other forms available in the ocean. But if the temperature goes up, coral and some plankton species will not be there, which are a big sink of carbon dioxide in the atmosphere. And if sea level increases, even in a country like India, almost 1 billion population will be affected because if sea level covers the edges of our land, that is the coastal area, then people will have to escape from there. Their agriculture will be wasted. They will have to find new places and they will have to migrate. All these things because of increase in the temperature, and the root of this is climate change, which is happening because of generation of heat, pumping of heat into the atmosphere due to, for example, our thermal power reactors. Therefore, constantly people have been advocating that we should use nuclear power, we should use other friendly technologies like solar and wind power or hydroelectric dams. But we know that there is a problem with the hydroelectric dams. Nobody likes to make now huge dams in the mountains where you have water at the height. Now people are not in the favor of making huge dams because that destabilizes those mountain zones. So that now fashion is going less and less. What we are left with? We are left with solar energy. At the same time, we all know that the impression given that solar energy is completely safe is also not a correct thing. The reason is that when we make those panels, we are spending energies. So we have already done some pollution. In the next stage, after 15 or 20 years, when the solar panels are disposed, there will be such a huge amount of solar panels, which also can contain some toxic stuff. We will not know how to dispose that many solar panels. So that is going to create a problem of pollution of soil. Similarly, wind is very good. Of course, it's not that it does not cause any pollution, because when we make the steel required for those windmills, we have already caused some pollution. Now people are talking about hydrogen. But the interesting thing is hydrogen is zero pollution fuel when you use it. Because if you burn hydrogen, what do you make? H2 plus O2. What do you get from the reaction? H2O, that is water. Water is not polluting. So you believe that hydrogen as a fuel is very safe, very good. It does not cause pollution. But the process of making hydrogen causes pollution. Whether you make it from the methane, whether you make it from water, and even if you want to make hydrogen from water, how do you do that? You do it by electrolysis, by passing electricity through it, and that electricity is generated by burning coal in some thermal power reactor. Unless we find what is being touted as green hydrogen, hydrogen is not a very good fuel because during the making of or preparation of hydrogen, we are polluting. Then comes nuclear energy. Nuclear energy, if a power plant based on nuclear technology runs one full day, at the end of it, the total ash or the total pollutants generated in this process will be something like a brick. Whereas hundreds of times more or thousands of times more ash will be generated if you are running a thermal power reactor. And you know that there are problems. The villages which are near thermal power reactors get covered by ashes. Lot of carbon dioxide and carbon monoxide is going into the atmosphere because of the thermal power reactors. But because coal is available, a country like China, for example, finds it much more convenient to use coal than any other method. Time will come when we will be forced to stop it. So we have to seriously think about nuclear energy. In our country, we already have quite a few nuclear power plants which have been established with help from different countries, with France, with Russia, with US, and other countries. And we are establishing more and more plants. But as Umesh had also indicated in the beginning, sometimes there are people who try to spread canon about nuclear. And that is a misnomer. I have also been to a nuclear plant in Narora, where everything was very good. Water was clean. There was a lot of vegetation. There was a lot of fauna. There was flora. There was fauna. Everything was fine. But then some people published in a newspaper something very, very disturbing. It said that because of this power plant, the Ganga near Patna was getting polluted with radioactive stuff. Now, this was a complete lie. But then people believed it because the argument given was that there were dolphins in the Ganges. Gangetic dolphin, we call them. Hardly 1,000 or 1,500 of them are left in the world, near in Brahmaputra, in Ganga, only in this part of the subcontinent. And people said they were going blind because of this radioactive material coming from the nuclear power plant. But then I did some study on the internet and in some books. And what did I find? I found that the Gangetic dolphins are born blind. So they did not become blind because of any nuclear effluents. They became blind because they were like that since birth. They navigate using sonar waves. So when I talked about it in different lectures, I published it in some of the newspapers, and then maybe other people also did it. And then people started realizing that this was a false thing which was being propagated by people who were against nuclear energy for whatever reasons. And that was time when Kudankalankam power plant was being established, and this was deliberately spread to confuse the people. But now many people know that nuclear energy is not associated with any such thing. As Umesh said something very good. The moment when somebody talks about nuclear, the first thing that comes to people's mind is nuclear bomb, which is untrue, because we know that something like 75, 80 years back, it was used by the US against Japan, but after that, no country has been attacked with nuclear bomb, and in all likelihood, no country will ever be attacked by nuclear bomb. Yes, there have been some accidents in case of nuclear power, but they were all because of human beings' error and not because of the nuclear technology or nuclear energy. There was a case of 3 Mile Island in the US, but nobody died in that incident. There was a case in Japan, Fukushima, everybody knows about that. But then there was a complete mistake on the part of the managers because, number one, it had already been recommended that the wall height should be increased. And it was not increased. Therefore, the water, because of tsunami, entered the plant. Number two, this plant was already scheduled to be decommissioned. It was just being run against the advice. In fact, this was not being maintained. Even if you have a dog in your house, and if you don't maintain it properly, one day it's going to bite you. Third thing was, at that time, it was a very old technology, very old technology. Nobody is building power plants like that. Nowadays, even if power goes down, the Cooling of the central tower of the nuclear plant will continue because this will be based on gravity, which is never going to vanish. So, as I said, there were key errors made by human beings there. They were running the plant against the advice of the company. They failed to raise the wall which protected it from the seawater. Number three, this was based on very obsolete technology. Number four, it was not being maintained. And number five, this was obviously a carelessness, and the plant should have been shut down long ago. So it was human error which can happen in anything. And you perhaps know that the total number of people died because of nuclear plants is almost zero. Whereas 1.5 lakh people die in road accidents in our country. More people die because of steam from the boilers in our country. And we have not had a single death because of nuclear energy or nuclear power plant in our country. In fact, in any country. Therefore, this is a misnomer to say that this is not safe. Please do not associate nuclear energy with nuclear bomb. They are very different. It's like an animal running amok in the traffic. That is a nuclear bomb, where you are not controlling the rate of the reaction. Whereas nuclear energy is a controlled generation of nuclear energy, which we use to heat water. That water gets changed into steam. That steam runs the turbine, and those turbines generate electricity just as in any other power plant. Now, if you look at the global scenario, still, as you can see, most of the people, 86% of the energy is being generated using fossil fuels. Even today, there are some small countries like Belgium and some other European countries which are generating almost 100% of their energy using nuclear plants. But then there are very few. In our country, only it's only a few percent at present, but gradually there is an emphasis on having more and more nuclear reactors. And very soon we will be establishing some more nuclear reactors. So we will be using more of nuclear energy. Actually, when we choose certain energy source, we try to see whether source is possible to tap technologically. As I said, earlier people were not using gas, but then we started using pressurized natural gas as fuel. We started compressed gas as a fuel. Today in our houses, we use a gas for our burners, for our stoves. We use them in our vehicles. They cause much less pollution compared to petrol and diesel, but still they cause pollution. One day, if we are able to use hydrogen after producing hydrogen without pollution, that will be a very great situation when we will be burning hydrogen to get energy and only water will be produced, there will be no pollution. That day is perhaps still a little bit away. One day, we may also get fusion energy, which is next step of nuclear energy. What we are doing now is fusion energy. We break a uranium atom by bombarding it with neutrons. But in case of fusion energy, we fuse two light nuclei like deuterium or helium-3 together to produce heavier element. And in that process also, energy is generated. Perhaps that may take a decade or maybe even more. But whenever we talk of energy, we should look at it in this way. We should know how much pollution it's causing when that fuel is produced. We should ask how much pollution it is causing when this is being used. And if you look at hydrogen, for example, generation or production of hydrogen causes a lot of pollution. Use of hydrogen does not cause any. But the question is different in different fuels. Now, India and China are among two countries which use a lot of coal to generate energy. The projection is that by the year 2040, compared to 2016, the electricity demand will grow almost 4 times in our country. India is investing very heavily in solar energy, in wind energy, and now in nuclear energy. But still, we rely mainly on coal, which is not a very good situation. And power sector emission are therefore likely to increase by a factor of 2. So it's important that we focus more and more on nuclear energy, which, as I said, after running for a whole day, the whole plant produces a waste, which is hardly about a brick in volume. Yes, disposing the nuclear waste is something which is still a trick. People have found different ways, and so far they have been found to be very safe, and there has been no problem. But once we get a different type of reactors in future, which are not based on uranium, they will be based on thorium. And India has a lot of thorium. This also you should know. So if scientists are able to exploit thorium for generation of energy, this problem of nuclear or radioactive waste hazard will also be gone. I will also give you some example. When we make nuclear energy in the process, we do a lot of research on isotopes because isotopes are needed. Heavy water is needed, where heavier isotope of hydrogen is replacing common hydrogen. So we do a lot of research on isotopes, and in the process of getting nuclear energy, India has, like many other countries, learned that these isotopes can be very useful in our research. These isotopes like tritium, which is H3, carbon-14, which we use for dating, aluminium-26, which we use for dating, potassium-40, which we use for dating, cobalt-60, which we use in cancer therapy, rubidium-87, which we use for dating. Similarly, there are isotopes of uranium, uranium-235, 236, and 238, which are very useful in our work, in research. But then there are other things which I'll just tell you. Just this brief view I will give you of the type of power plants for energy generation being used all over the world. The first is the hydroelectric power plants, which means water has been taken to mountain tops by the sun. By the energy of the sun, water evaporates, reaches the top of the mountain, and from there, when that water precipitates and comes as a stream, we use that stream to run turbine and generate electricity. There are coal-fired power plants, there are diesel-fired power plants, there are geothermal power plants, which means we know that as we go to the center of the earth, the temperature goes on increasing. So we send normal water to a depth, it gets heated and comes back, and we are getting heat. There are gas-fired power plants, there are solar power plants, there are wind power plants, and now people are very strongly realizing that nuclear power plants are a very good substitute for many of them. So nuclear power plants are going to be our future. But why nuclear reactors and nuclear energy? We know that energy is a must. Energy drives this world, and we need it. Nuclear energy does not pollute, even though disposal of the radio waste is a very, very technical issue. We are handling it very well. Modern reactors are safe. As I said, nobody has died because of a nuclear power plant, but we hear of death in so many factories, we don't close them. 1.5 lakh persons die every year in road accidents in our country. Nobody has stopped driving or walking on the road. Then, if you look at the defense needs, radioactivity based or these nuclear power plant, nuclear energy can be very useful for submarines, and India has got submarines which go underwater and they don't have to come up to the surface very often. They can remain underwater for a very long time, and therefore they serve our defense very well. But in addition, isotopes are useful in many other ways. They are used in research. For example, you may be surprised. Isotope is something with which physicists deal and chemists deal. But this is the botanist who use these isotopes as tracers, because what they do is they add some of this radioactive stuff or these isotopes in their chemical or the food for the plants, fertilizer. That fertilizer is taken by the plants, and that isotope, radioactive isotope, reaches different parts of the plant. Because this is radioactive, it can be detected. Therefore, people know how much nutrition is reaching in each part of the plant. Similarly, if you want to analyze, if you want to find out the chemical composition of some stuff, there is a method of neutron activation. I will not go into details here. There is a method of neutron activation, and you can analyze the chemical compositions of many things, which was not otherwise possible because the amount was very small. People are using irradiation because you want to increase the shelf life of vegetable. It's also being used in healthcare, and I will tell you about them. So this E equal to mc square, famous equation given by Einstein, which means mass and energy are like Atma. They can never be killed, but they can get converted into each other. But how? If you bombard a uranium-235 nucleus with, or an atom with the neutron, then tremendous amount of energy can be produced because first this nucleus absorbs that neutron, becomes a heavier nucleus with an atomic weight of 236, but then this becomes too big to remain stable, and it splits into krypton and barium, and in the process, energy is also released, which was actually so far latent, and it's now released, and this energy is used for heating water, which gets converted into steam and runs the turbine. Now, when we use nuclear plants, there will be no pollution as happens in the case of coal power plants, and therefore the villages which are near these nuclear power plants will look as green as they were before, unlike the villages which get completely destroyed near the coal-based power plants. So, okay, I can skip this thing. Now, again, I'll come back to the same point that the nuclear energy and nuclear bomb are different. They are not the same. Whereas a common person thinks that they are one and the same thing. A bomb is energy left to explode uncontrolled once started, and hence it's destructive. We have seen it in 1945. But nuclear energy by fusion, which may be in future, or in fission, this is not an uncontrolled release, and therefore this is not. According to the reports, there are something like more than 450 nuclear power plant reactors and 226 nuclear research reactors in operation around the world. This is the report from 2019, and number may be increased a little bit. So you know that there are almost 700 nuclear power reactors working in the world. Do you hear of any accident? Do you hear of any harm? Do you hear of any deaths? You don't hear of them. The reactor, therefore, is very safe. And even if the reactor is, but one thing we should understand, that if there is a nuclear fission reactor, which are being used in the world, even if we shut down the reactor, the reaction happening inside its core will not immediately stop. Therefore, it's important that the temperature there is brought down and the reactions slowly stops. And people use the cadmium rods. They dip the cadmium rods inside, they absorb the neutrons, and gradually the reaction stops and no more heat is produced. So there are ways which are very safe. In addition, there are water reservoirs which start slowing down even if there is no power, because this is by gravity, and they start cooling down the core. So there is no possibility that the meltdown which happened in Fukushima can ever happen. India is capable of making nuclear bombs. We have seen it, but is also committed not to use it. Most of the countries in the world are agreed upon one single agenda, that they will not use nuclear bomb ever. But nuclear energy is something which will have to do. As I said, in INS Arihant, this is a Navy shipbuilding center at Vizag, who built it, that is Indian Navy, and this is a submarine of S5 class. It was commissioned in 2016, and it's working, and we have now nuclear power ballistic missile submarine which are functional. Every year we have this problem of air pollution in cities, which is because of stubble burning, which is because of thermal power reactors, which is because of our vehicles which are consuming petrol or diesel. If we could have nuclear power in bigger amount, then these problems will be solved because that energy will charge the batteries and those batteries would be used in our vehicles. It's also another problem of groundwater. We know the groundwater is reducing, but equally important is the quality of groundwater. And lot of fluoride, nitrate, arsenic, iron, and heavy metals are going in there, which have to be stopped. And many of these things are because of power reactors. We are adding wind and solar power capacity addition, but as I said that, they also have some attendant problem. So we do not have to just depend upon one kind of power, say only wind, only solar, because first thing, we cannot have wind mills or wind installations everywhere. This is possible only where there is sufficient wind, there is sufficient area, there is appropriate altitude. Similarly, solar panels cannot be spread everywhere because land is limited and we want some area to be open to sunlight. That is where we do the agriculture. Therefore, we are talking of a bouquet where different types of energy would be used. Now, if we are not careful, if we don't think in terms of appropriate choice of energy, the possibility is that there will be sixth extinction. You know that the world has seen major extinctions where more than 90% of living species on the earth died. If we don't mitigate, if we don't slow down climate change, if we don't stop pumping lot of carbon dioxide and dust and pollutants into the atmosphere, the sixth extinction may not be very far. The earth may not remain an inhabitable place. We are seeing it that the weather cycle is completely disturbed. The temperature is going up in general, but in many places this is going down and there are more glaciation. Vegetation is changing. Cattle are giving less milk. Crop is getting destroyed because there is no rain at the right time. People are getting disturbed because of flooding. They have to leave a place and move to another place where they cannot earn their livelihood. People are disturbed because they have to move from one place to the other because there is no water or it's too hot. And ultimately, this takes away their livelihood and they're getting poorer and poorer. If a society is not at rest, if there is turmoil in the society, if people are hungry, there is a report in a journal like Nature that the possibility of social unrest and disturbances increase if the society is not happy. This has happened in the past in China, where the dynasties were disturbed because there was a disturbance in the weather pattern. There was not good crop, and therefore people revolted and the dynasty changed. Therefore, it changes even the history. I hope that the nuclear is not anymore unclear to you. Nuclear energy is something which is the hope of the future. In India, we have a good number of nuclear plants. We have in Kulankalam, we have Kaiga, we have in Uttar Pradesh, we have in Rajasthan, Rawalbhata. We are building them at several other places, also in Karnataka and in several other places. And some new plants will also be coming up. And India will be generating energy without polluting this atmosphere. Atmosphere is what gives us oxygen. If the atmosphere is polluted, we will not be able to survive. And as you can see from these examples, that nuclear energy is safe. It causes virtually no pollution. There are hardly any adverse events of reports because of this nuclear energy. And even in the few reported cases, the problem was not with the energy or with the technology. The problem was with the people who handled it or did not handle it properly. Nuclear energy can help us in avoiding this problem of pollution, this problem of climate change, and several other problems which we are facing today. And at the end, I must tell you something which talks of positivity, which talks of life, which talks of saving lives because of nuclear technology. You know that these days people live longer, and therefore there are many people who are troubled with diseases like cancer. But if you want to find in which part of the body cancer is, it becomes too late. But now, nuclear science has given us a technology known as positron emission tomography or PET, which can tell if a patient is having cancer in certain part of the body. What is done is they take radioactive isotope like oxygen 15, carbon 11, nitrogen 13, or fluorine 18, which is very popular. Fluorine 18 is very popular. They inject, they first label it, they make this a part of some glucose, deoxyglucose, and that glucose is injected into the body of the patient. Once it goes into the body, it travels. Now, you know, by cancer, we mean uncontrolled growth of. Wherever cells are growing at a higher rate, this radioactive tracer will also be reaching there in a higher amount. And once this reaches there, it has a short half-life. Half-life may be a few minutes. As you can see in this list, it may be 2 minutes, 20 minutes, 10 minutes, and like that. So after some time, it starts decaying. But when it decays, a particle known as positron is emitted. Positron is just opposite of electron. This is an antiparticle of electron. Electron has negative charge, positron has positive charge. So when positron comes out, it reacts with the electron, which is there everywhere in our body, in the atmosphere and all. When electron and positron meet, they annihilate. In a way, they kill each other. They both, in a way, vanish. The matter vanishes, and all of it is converted into gamma rays. Now, gamma rays can be detected. As you can see in the picture, the patient is slided inside a chamber. The chamber has gamma ray detector on all sides. This patient has been injected with this radioactive tracer, and inside, when that decay happens, positrons are produced. Those positrons annihilate with the electrons. Gamma rays come out from that part of the body where there was cancer, and people are able to find out, the doctors are able to find out in which part of the body the cancer is. So the early detection of cancer. Similarly, radiation is being used in agriculture because high doses of radiation cause the seeds not to sprout. So an appropriate dose is given so that the shelf life increases. Sometimes we can get new varieties of seeds which have very good and new properties, and therefore our agricultural scenario improves. Similarly, radiation has been used, which is again, we get them from the nuclear reactors. In fact, World Food Prize was given in 1992 to Nipling and R.C. Burla because they developed a technique to sterilize by radiation things like screwworm files, fruit fly, Mexican fruit fly, and their life cycle is disturbed. They cannot produce next generation. And in many places like Australia, this had become a very serious problem. And now people are solving with the help of nuclear technology. We have isotopes used like americium-241, which is used in smoke detectors. There are two plates. In between, there is air. There is a source of a radioactive isotope, americium AM-241. This ionizes the gas, and there is an electric current. You measure that current. But if there is smoke, that smoke will get into this space and will not allow the alpha particles from AM-241 to ionize the gas. The current will be reduced, and it will be detected, and there will be a siren which will tell you that there is a smoke. So you know now that nuclear energy is indeed a great friend, and so are nuclear science and technology. So I told you in the beginning that climate change is like a beast. You are poking it. It's up to you what to do. If you cannot control it, it will kill. If you can control it by using appropriate technology like nuclear technology, nuclear energy, so you will be saved. This is just like the advertisement of the helmet. सर आपका है, हेलमेट आपका है, आप पहन लीजिए तो आपकी जान बचेगी, और वरना सर आपका है, बचिए। So thank you very much for a very, very patient listening. Thank you so much. Please unmute yourself.
Yes. Thank you very much. I think you have covered much more than the environment. It's not only the environment which is in our surrounding, it means outside, but I think you have covered right in your drawing room also, maybe in a hospital, means in our surrounding where we are living. I think we'll take up some questions if we have, or since the number of participants are less, I think we can ask them. They can directly, if they're interested, they can ask directly also. Rajesh, is it possible those who are willing to ask question directly, because in chat box I don't see anybody has written out there. And you would like to ask question, they can raise hand, and then we allow them to ask question. Rajesh, you just monitor that. Meanwhile, yeah, okay, we have one from Chitra ma'am and then Meg Shah. So we can start with Chitra ma'am. Yes.
Very good evening to all, and very nice to see and very pleased to see CM sir and Umesh sir. Sir, if I want to know that if nuclear energy is so safe, what about the Chernobyl accident?
Nuclear energy as such, you see, there are two things. As I said, there is no problem with the technology. It's like a knife. You can use a knife to kill somebody. You can use a knife to cut a vegetable or fruits. Second thing is transparency. If there is some problem, it should be admitted and it should be rectified instead of hiding it. So the main, and the most of the time, as I earlier also said, the problems are human problems and not with the technology or technique. Anything, as I said, there are 1.5 lakh deaths occurring in India every year because of accidents on the road. We don't stop moving. We keep driving. So similarly, in the case of nuclear energy, if you don't follow the advice given. Second thing, wherever such things happen, they were obsolete technology. In case of, for example, I told you about the Fukushima case, that technology was so old that it had been recommended to be decommissioned and the plant was to be decommissioned. It's only that they dilly-dallied on that. They stopped the maintenance but continued using that. If people are not careful, if people don't listen to the scientists and engineers, if people, for whatever reason, then there is nothing you can do. I mean, if a patient doesn't listen to the doctor, a doctor would be helpless. So the problem was nothing, not with the nuclear science and nuclear technology. The second part of nuclear bomb, yes, it's a reality, but this again, if people kill each other with the stone, if people kill each other with the sticks or with knife or anything, people will find ways to harm each other if their thinking is bad.
It's much more like what happened in Union Carbide in Bhopal. That was also almost on similar line. That if you don't maintain, if you don't listen to the engineers or the people who are responsible, then accident do bound to happen. But as you said, right? Yeah, if they would have accepted, but sometimes they don't want to take it to the public, and they try to suppress the facts, and then people have more suspicion about that why they are not. So that maybe around that time, I think it was in when USSR was there. So they had some nuclear sites, and perhaps this Cold War was also there. Means both the superpowers. So perhaps they were not interested that there should be some inspection by international authorities. So yeah, that may be. Okay, make sure you can unmute and then ask question.
Yes, sir. Good evening.
Good evening.
Good evening.
The session was very good. I learned many things. And what I found is the main goal of any energy is that to run the turbine to generate electricity. So I want to know that about the fusion technology that the sir said that the next level of the nuclear technology. So what is the fusion technology?
Okay, you know about that at present the nuclear energy is being generated by breaking a uranium atom or uranium nucleus, the U-235, yes. Right? You bombard it with the neutron, it splits into two, and in the process, neutrons are released with energy, and energy is also liberated. Now,
Yes, sir.
in case of fusion, the process is just the opposite. For example, you burn hydrogen and produce helium. Now, for the younger people, I will just give an example. For example, you may have 1 kilogram of besan, 100 grams of sugar, and 100 grams of ghee or butter. You mix them all and you make some laddus. And when you weigh them, it turns out that this is not 1.2 kilograms, it's less than that. So that missing mass, which is termed mass defect, where did that go? That actually got converted into the binding energy. When you break this laddu, the binding energy is released. So that is what happens in the case of fission. But in case of fusion, you are burning heavy hydrogen, for example, deuterium or helium-3, and then you are producing helium-4 and other things. And in the process, also energy is released. So this is just opposite of nuclear fission. But fusion right now is not really. People have generated electricity, but the self-sustainable fusion, which means you input some energy and you should get more energy out of that, considerably more energy out of that. That has not been possible. Just a few months back, there was a success story. They were able to generate energy, but not sustainable. So it may take a little bit of time because the problems are very serious. For example, one of the main problems is the stability of the plasma. Plasma is in the shape of a donut or a bada or an inflated tube of carbs in that shape. And this is a quasi-neutral mixture of particles. There are positive charge, there are negative charges, and they are kept in place using strong magnetic fields, supermagnets. These strong magnetic fields are required, which are not very easy to generate. Second thing, those magnetic fields has to be very, very stable. If they change, that will affect those charged particles. But this is not possible for a very long time, and therefore energy generation does not sustain for a very long time. But I'm sure that people are working, like ITER is an international collaboration in which India is also a party. Many countries of the world are there, ITER or ITER, they call it. And a lot of people are working together. Some parts are being made by India, by Institute of Plasma Research, through vendors or atomic energy and so on. Other countries are also making. So we hope that, in a very foreseeable future, fusion will be a reality, which, as I said, is just opposite of fission.
Yeah, sir. Okay. Thank you.
Yeah, Mr. Subir Kumar Bandyopadhyay. I can see your raise hand. So you can unmute yourself and then ask us. Rajesh? Yeah.
So am I audible right now?
Yes, you are audible, sir.
Sir, I'd like to ask you a question, sir. Good opportunity to me. Sir, fusion reaction generally deals with hydrogen. And I came to know that fusion reaction till may be uncontrolled. But already, say, near about when I was visited to Mumbai, say about 1 decade ago, that is deuteron, they have used up and much more efficiency, much more energy we are getting, electrical energy maybe, should be. So is it right now controlled fusion reaction? Or hydrogen, deuteron, if you use any nuclear reaction, that should be considered as a fusion reaction strictly. My question is that one, is it that strictly fusion reaction? If it is fusion reaction, right now fusion reaction is controlled or not uncontrolled?
Fusion
Am I clear, sir?
Yeah, fusion is controlled. Fusion is controlled reaction because you can control its rate of conversion. At what rate to generate the energy can be controlled, but unfortunately the energy generated is not adequate. One more thing I would tell you that earlier it was only deuterium which people thought they should be using, but you require much higher temperature. But helium-3, if you start the reaction with helium-3, you will get much more energy compared to deuterium. In fact, that's one reason why China has sent a mission to the other side of moon, because on the lunar surface there is a lot of dust. The soil is there, lunar soil or regolith. This is constantly collecting radiation coming from the sun, which includes helium, and a small fraction of that, something like 10⁻⁵, is helium-3. That helium-3 is getting enriched in the surface area of those grains. So what China is planning is they will be doing mining of that soil, bring it back to Earth, and this way they will get helium-3, which is present on Earth in very small amount. So that the helium-3, they say that they propose to use for fusion.
Yeah, I think there is no more raised hands, but if I cannot see at least on the screen. In fact, the gallery when we made in 2010 on 11, that shows and address so many things about the myths and things which are there in the in surrounding means, or it has been published in like at that time just before inauguration. I think this Fukushima happened, and then we added that also. There are many other benefits, like you mentioned, sir, self life. In fact, now it is 2010, and now we are in 22. So 12 years ago, we got some samples, irradiated samples of pulses, and we used them for display. And other set of that was without irradiation. And now, if we compare both of them, the samples which were irradiated and displayed over there, they are still intact. And because though they are sealed, so obviously, but other means the set of samples, they have become means totally eaten away by insects and all that, even though it was totally closed, no contact in air or moisture. So that is one thing, as you have already mentioned, that self-life, which is one of the very, very important, even in cancer treatment, isotope. But sir, one thing is that all those isotopes, like which are being, you have shown a list of them, are they being produced only in reactors, or nuclear power plants are being used for that means?
No, nuclear reactors are used. They can be produced in accelerators also.
Yeah.
Because you bombard something with another energetic particle, so new isotope can be produced. But many of them are produced in by DRC and using reactors.
I think Rajesh, if anything is there, otherwise those who are present here, I think we have shared the link. You can download your certificate after giving some feedback on that. They have some process. Rajesh has shared already the link. With this, I think we can close. Actually, we have one more lecture at 6 o'clock. That will be on artificial intelligence, and that's exclusively for teachers. Those who are here, I think I can see a couple of teachers also here. If they are interested, they can contact Rajesh. I think he can share link, but that will be on artificial intelligence and exclusively for teachers. It is with some Dalvi Foundation. They will be along with that. So there is one expert from their side. And those who are close to Delhi, they can visit the gallery in National Science Center, Delhi, to know more about nuclear and its benefit, nuclear power, nuclear energy, demand, and so many things. And we will soon be renovating this with the help of NPCIL, with whom we are organizing this series of program under the banner of Azadi Ka Amrit Mahotsav. So we are thankful to them also, and we are thankful to Nautiyal sir, who has always been kind enough. This was the first in the series, so you have started. There will be two more. Next one is in a hybrid mode. It will be at Science Center as well as online, but that will be at 11 o'clock in our auditorium, and we'll go stream live on Facebook. The topic will be nuclear energy power and inevitable option. As you have already started that, so it will be one step further, and then there will be one lecture on 6th of August. That will be by Mr. S.K. Malhotra. Now he is the secretary in Indian Nuclear Society. And he will cover about taking it further. I think there's a series of lectures. That's why public perceptions, myths and reality, something like that, about nuclear power, as we have started. So I will request those who are present, they can share it with others also, and be there with us on these 3 coming Saturdays, 30th as well as on 6th. And we are planning one panel discussion also that is yet to be announced, because we need more people for that. So thank you, sir. I will be in touch again with you, sir. Nautiyal, sir. Okay. So we are concluding with a lot of thanks to all our teachers, students who are present here and spare time, and those who want to continue at 6 o'clock, they can come again, taking this link from Rajesh, or they can write in any of the group. They can share the link. Okay. Thank you everyone present here.